Hello there, Mr. Sutton here, bringing you the IM3 3.2 Extra Practice Number 2 solutions on adding and multiplying complex numbers. There's a puzzle that goes with this one. Let's go ahead and take a look at that. So here's the puzzle that goes with that extra practice. We're trying to solve the riddle of why did Jimmy do well on the math test after drinking orange juice? And the idea here is that for questions 1 through 11, we need to go ahead and simplify these, and then we're solving questions 12 through 17 down here. And in any case, whenever we get the answer to one of these, we need to look up the letter that goes with that answer, and that's what's going to go in the blank down below. For example, if I solve one or simplify one and I find that the answer is n, it's not, but let's say that it was, then I would put an n above blank number 1 right here. So let's go ahead and get to the bottom of this mystery about Jimmy's math test. For the opening problem, we're trying to simplify the square root of negative 49. Since we have a negative inside a radical, we can get rid of that negative by taking out an I, basically breaking this up into the square root of negative 1 times the square root of 49, and the square root of negative 1 is I. So the square root of 49, that's going to be 7. So we have 7 times I. And looking for that answer down below, it's tempting to pick this D right here, this plus or minus 7i, but this isn't plus or minus. This is just positive 7i because we just have a square root kind of floating in space. There isn't like a plus or minus unless you solve an equation. So we need to pick this 7i right here with n next to it. So that means above spot number 1, and there's only one of those, I'm going to be putting an n. For this next problem, we have negative radical negative 100. I'll start by taking out an I from that radical to give me negative I square root of positive 100. And then the square root of 100 is 10. So this is going to be negative 10I when all is said and done. That's this one right here, E. So I'm going to put an E above 2. Up, we're simplifying the square root of negative 18 times 3. We'll start by getting rid of that negative by taking out an I. So I can rewrite this as 3i radical positive 18. And then 18 has a perfect square that I can break that up into. We have 9 times 2 radicals for both of those. The square root of 9 is going to be 3. 3 times 3i is going to give us 9i. So we have 9i square root of 2. Looking for that answer down below, I see that down here. This is going to be a t then, and that's going above spot number 3 all the way toward the end here. For number 4, I can start this problem by getting rid of that negative inside the radical by taking out an I. So I can write this as negative 5i radical 9. And 9 is actually a perfect square, so I'll just go ahead and square root that. Square root of 9 is 3. 3 times negative 5i gives us negative 15i. And that's right here with n, so I'm going to put an n above 4. This one we have 3 plus the square root of negative 25. Negative can be taken out by taking out an I from that, so we have 3 plus I radical 25. 25 is actually a perfect square, it's 5 if I square root that. So I've got 3 plus 5i. And these are not like terms. We have a real and an imaginary number, so that's as good as it gets. So that looks like a right here, 3 plus 5i. So let me put an a above spot number 5 here. For this next problem, I'm trying to simplify the sum of these two complex numbers. Typically, I just want to start by getting rid of the parentheses. I can get rid of both of those basically for free. I have an invisible 1 outside of each of these parentheses getting distributed, so I can just write this as 3 plus 2i plus 2 plus 7i with no parentheses. I basically distributed an invisible 1. Now I just have to combine like terms. 3 plus 2 is going to be 5, and then 2i plus 7i is going to be 9i, so then we end up with a 5 plus 9i. And I can't combine those are not like terms. So let me just find 5 plus 9i down here. That looks like choice O. So let me put an O above the 6. We're trying to simplify this expression here where we're subtracting some complex numbers. I'm going to start by getting rid of my parentheses. This first one I can lose for free because there's just an invisible 1 times all of that. So we have 4 minus 5i. And then for this next one, I have to multiply everything in here by a negative 1 to get rid of this negative out here. So this will be a positive 10 minus 3i. Combining like terms now, 4 plus 10 gives me 14, and negative 5i and a negative 3i combine to give me a negative 8i. Let me see if I can find 14 minus 8i down here. Well, it's the very first term. So that's an e, so that's what I'm going to put next to the 7 over on this end. For this problem, to simplify it, I'm going to start by distributing to these parentheses to get rid of those. So we have 2 times everything in this first one. That'll give me a 6 plus 12i. And then multiplying negative 3 by everything in the second parentheses, that's negative 21. And then negative 3 times negative 5i is a positive 15i. Combining like terms, we have 6 minus 21. So that's going to be a negative 15. And for the imaginary numbers, 12i and 15i adds up to give me 27i. So negative 15 plus 27i, that's right here, that's an S. So let me put that next to the 8. On this problem, I'm trying to simplify some things that have negatives inside square roots. So definitely I'm going to want to take care of that before I try to combine anything. And I can also, I've got some parentheses here that I can actually lose for free. There's a 1 times each of these parentheses, so they might as well just not be there. So I can rewrite this first thing as 2 plus the square root of negative 25. If I take out an I and square root the 25, that's going to give me a 5i. And then over here, this is a plus negative 8, so minus 8. And then we have plus negative, and then this square root of negative 9, that's actually I times the square root of 9, or 3i. So I'm doing a minus 3i when all the dust settles over there. Combining like terms, 2 and 8, negative 8 adds up to negative 6. And then 5 minus 3i gives me positive 2i. So negative 6 plus 2i, let me see if I can find that. That's right here, that's an e, so 9 is e. Two numbers that may be complex numbers after we simplify those radicals. Let's go ahead and get rid of these parentheses first though. So first parentheses, I have an invisible 1 out in front. Distributing that just gives me what I started with, 3 minus 5, and then instead of writing radical negative 7, I'm going to take out the I on that. So I'll have negative 5i radical 7. And now this next negative, I have to distribute that to both things in the next parentheses. So this is going to be a minus 4. And instead of writing minus 3 radical negative 7, again, I'll take out the I. So that'll be negative 3i radical 7. Let's combine like terms now. 3 and negative 4 gives me negative 1. Negative 5i radical 7 and negative 3i radical 7, they both have an I and a radical 7, so they are like terms. I can just combine those. Negative 5 and negative 3 gives me a negative 8 and an I radical 7 to go with that. So let me find that down in my answer boxes here. Looks like this one right here, that's a very weird looking minus right there, but we'll take it. So I'm putting a C next to 10, and that's right there. For number 11, in some ways it's a lot like number 10, only it's going to take a little bit more time to do this one, even though we have a plus instead of a minus between the parentheses. So first, let's get rid of those parentheses. We've got just 2 minus, and I'm going to take out an I on this one. I'm also going to split up 18, because 18 is divisible by a perfect square. We can break that up into 9 times 2. So I have a minus 7i radical 9 times radical 2. And then moving on to my next parentheses, it's just a plus parentheses, so I can just lose the parentheses without changing anything else. So we've got a minus 3. And now this is going to be a 4i. And now the square root of 50, I can break that up into perfect squares as well. 25 times 2. Let me keep simplifying now. So this 2 is what it is, nothing to change there. But the square root of 9 is 3. So this is going to be 3 times 7i. This is going to be a minus 21i radical 2. So a 2 minus 21i radical 2. This 3 is still what it is, subtract that. And now square root of 25 is 5 times 4i gives me 20i to go with my radical 2. And I've simplified the radicals as much as I can. Now let me see if I can combine some like terms. 2 minus 3 gives me negative 1. And then I have I radical 2's here, both of them, so I can combine them. Negative 21 and positive 20 gives me a negative 1 I radical 2. And let me see if I can find that answer. It looks like that's right there. It's going to be a t, so I'm going to put a t next to number 11 here. For the rest of the problems on this puzzle, I have to solve equations instead of simplifying expressions. So for this one, we have x squared equals a number, so I can actually just go straight to square rooting both sides of the equation. Whenever I square root an equation, I do have to remember to throw in a plus or minus. It's not built into the square root, but both positive and negative roots, when you square them, give you the original. So I'll have plus or minus square root of negative 81. And since I've got a negative going in a radical, I'm going to take that out as an I immediately. So let me write plus or minus I radical 81. And now the square root of 81 is going to be 9. So this will be plus or minus 9i. Looking down below, that's right here, that's r. So I'll put that next to the 12. We're trying to solve the equation x squared equals negative 2. So just like before, I'm going to be able to square root both sides right away because I just have an x squared on the left. When I square root the right side, again, I have the plus and minus. And since I'm going to have a negative inside my square root, I'll take that out as an I. So I'll write plus or minus I radical 2. And I can't simplify the square root of 2 anymore, so this is actually my final answer, which I find down here below. This is going to be an h, so 13 is an h. On number 14, we can solve this equation by moving this 49 over to the right side. So subtracting, we have a negative 49 over there. And then if I square root both sides, I'm going to end up with plus or minus square root of negative 49. Take out an I, and also square root the 49. That's going to be plus or minus 7i. And that's down here as d, so 14 is d. For this next equation, I'll start this one by subtracting the 50, so I can get that x squared all by itself. So we have x squared equals negative 48. And now if I square root both sides, I'll have plus or minus, take out an I, because we have a negative inside the square root. And now 48, I need to split that up. Let me think here. Perfect squares that go into 48. 16 times 3 works. 4 also worked, but 16 is better, because if I use 4, I'll have to simplify later on. So let's make this radical 16 times radical 3. Square root of 16 is 4, so then we end up with plus or minus 4i radical 3. And is that anywhere here? Did I get this right? Well, it looks like we've got a match over here for C, so that's 15. For this one, I have things on both sides of the equation that are squares and constants. So let me get my x squareds on one side and my constants on the other. So let me see here. I can subtract x squared over to the left side to get 2x squared. And then I'll subtract this 12 over to the right side to get negative 32. I can divide both sides by 2 so that I have x squared truly by itself. So that'll be x squared equals negative 16. And then if I square root both sides, I can take out an I. This is going to be a plus or minus 4i. Square root of 16 is 4. So plus or minus 4i for this one. And that's w right there. Pretty easy to find. So let me put w in spot 16. We come at last to the final problem, final boss battle. This one, before I start moving things around, I think I want to distribute to get rid of these parentheses. Can't really do it any other way. So distributing this 5 here, we have 5x squared minus 4 times 5 is 20. And then over on the right side, 3 times 2x squared, that's going to be 6x squared. 3 times 6 gives me a plus 18. And now let me get my x squareds on one side and my constants on the other. If I subtract the 5x squared over to the right side, I don't like having x squareds on the right side, but in this case, it'll let me have a 1x squared over there without having to mess around with negative x squared on the left side. Also, I want to then move the 18 over to the left side. So subtracting 18, negative 20 minus 18, we've got negative 38. And then subtracting 5x squared to the right side, that's going to be 6 minus 5, 1x squared. Now I can just square root this thing. So I can take out an I. I've got plus or minus I radical 38. And 38 actually is not divisible by any perfect squares. It's divisible by 2 times 19, but there's nowhere else you can go from there. So let me see if I can find that here. Yep, I radical 38 plus or minus. So that's an A going in that final spot for 17. Now that we've filled in all the letters, I think we can solve the puzzle. So why did Jimmy do well on the math test after drinking orange juice? So we have a HE for he was, and then this is one big word here, concentrated. Concentrated like orange juice. All right, till next time, Mr. Sutton signing off.